When we study machine learning, they are often focus on how to clean data, train models, evaluate their performance. But there's one very important step that is missing here. It's actually the teamwork. So let's talk about how you can implement those teamwork practices in your projects and what should you do to become a valuable team member when working on real life projects.
Here is the input. Raw, very often messy data gets fed into some magic box. And this magic box, this is where all the magic happens, all the analysis, deployment, model training. And then results of this magic are consumed and deployed to the production to serve happy users. Easy, right? But that's the practice. What's the difference between theory and practice? In theory, they are the same. In reality, they're not.
The reality of teamwork. At university or during online courses, we are often taught how to work with data and how to create models out of this data. But the teamwork skills remain at a very basic level. And it's not surprising because teamwork skills are very hard to train during the online courses. But without them, you will not survive. As data scientists, we often like to focus on breathtaking new algorithms or new model architectures that we want to implement as soon as possible. But very few people like writing clean code, writing unit tests, or documenting the whole thing. And moreover, communication with business users becomes pretty hard, especially towards the end of the project. Trust me, poor communication has killed more projects than bad models. In fact, bad models often are resulted by poor communication. For example, there is a large number of prerequisite steps you have to do as a team before jumping into the modeling part. You need to understand the problem, understand the data and the process that generated it, validate and talk through with the users about all the anomalies that you observe in the data, and understand how the model is going to fit into the existing IT infrastructure. Remember, garbage in, garbage out. So make sure you plan enough time for these steps before you start trying new fancy modeling algorithm. And this whole process actually requires a lot of communication with the business users. We tend to skip those steps before saying they are too technical so that the users will have hard time understanding it. But actually focusing on communication during the early stage of the project will allow you to build a very important currency. It's the most important currency in the whole project actually. It's the confidence between business users and you. Try putting yourself at the place of the business users. They have a problem. They invited some very smart people to work on this problem. These people come to them, give them the black box, and they have to appropriate results produced by this black box. And as a business users, you want to be confident that these guys, they understand you, they understand your problem, and they understand how this solution that you are bringing to them will give them real value. Pull requests. Remember, you are participating in a software project. So whatever code you write will be used by you and other team members for many, many times. That's why the code quality is a must. And that's why pull requests are essential to ensure the code quality. But working with pull requests is not about smashing the approve button. It's an opportunity for you and your team members to have a fresh pair of eyes looking at the code that they have generated and ensuring that the code quality and the architectural decisions that have been taken, they make sense and they can bring real value to the advancement of the project. First of all, it's worth mentioning that pull request is a great tool to enforce coding standards in your team. Of course, for simple code formatting things, you can use tools like Flake 8 or Black that will auto-format your code. But there are things beyond that. For example, the naming convention, how you structure your modules, etc. And this also can be standardized across the team. And that's why during pull request, pay attention to this. On the other hand, if your code is being reviewed by someone else, make sure that you don't take it personally. The person who is reviewing the code has made a very important effort to understand what you are doing and to propose a solution that might be more effective. So it's not about saying you wrote the bad code. It's about saying, hey, let's make our code better. And lastly, very important thing is that don't be shy about asking questions. When we are writing the code, we have a very clear logic of why we are writing it the way we do it. But it might not be obvious for the other people. So these questions will help to understand the way you were thinking and to challenge it or probably improve it in the future. Remember, Pull request is not about catching all the bugs in the code. A pull request is about code quality. So the more you do them, the stronger your team becomes in creating reusable and maintainable code that can be further put in production. Transitioning from Jupyter notebooks to Python files. Jupyter Notebook is a great tool for quick prototyping and experimentation. So when it comes to real world projects, your code has to be modular. And when you are writing this code, make sure that you don't write it only for yourself. For example, do not focus on writing the code that trains a model, but rather focus on writing a pipeline that trains a given type of a model with given parameters. In that way, the your code will be reusable by the other members of the team when they will want to train their own model. From my experience, the code repositories are very often separated into three main parts: feature engineering, model training and evaluation, and inference. Code reusability. Python has a very rich set of libraries that probably solve one of the problems that you are currently facing. So please make sure you do not reinvent the wheel. Try searching for these packages and see whether you can use them in your project. For project-specific repeating functions, put them into separate utility functions. When it comes to practice, for example, I have a set of functions that travels with me from one project to another, and these functions cover wide variety of features from data preprocessing to model training, hyperparameter tuning, model evaluation, model registry, and so on and so forth. These functions are pretty generic, but the more I use them, the more generic they become. When it comes to inference, make sure that your model is not just a model object, but it's rather a scikit-learn pipeline that includes as many pre-processing steps as possible into this object. Scikit-learn pipelines is a great way of automating these pre-processing trees and making sure that your model can handle the unexpected data correctly. Another aspect of code reusability is dependency management. So far, I've been widely using virtual environments and Conda environments for my projects, but the rule is always one project, one environment. Recently, we're thinking about switching to poetry. If you have any experience or feedback about poetry, please let me know in the comments. Unit tests. Write unit tests. Yes, even for data pre-processing. As I said before, you are participating in a software engineering project. That's why when you are contributing to the work of the others, first of all, you want to make sure that your code does not break the others' code, and vice versa. When the others will be modifying something, they want to make sure that they don't break what you have done. That's why unit test is a very important aspect. Usually, this adds from 30 to 50% of additional time required for the developer. But actually, faster development does not mean faster typing. Faster development means lower debugging time, and unit tests serve that purpose. They can drastically decrease the amount of time you will spend debugging your and someone else's code. Another very important indicator related to unit tests is their complexity. The rule of thumb says that if you have to write a very complex test to test your function, there is a way to simplify your function and decouple components so that you can test them separately and independently, and this will improve the overall architecture of your code. When you're working on large projects, you need to make sure that you've agreed on how the data will be structured in your project. Where do you store the input data? Where do you store the output data? Where do you store intermediary data? And how do you version it? Moreover, usually I also like trying to freeze the input data, especially the one that's coming from the production system. The thing is that the production's data has its own life cycle. It gets created, updated, and removed according to some rules that you might not be aware of. That's why the data that you have been using 6 months ago, you may not be able to reproduce it in exactly the same way. That's why you may please make sure that when you're working with raw production data, you freeze it at least for the modeling side. Second very important aspect is that the data in the storage should not be modified manually and direct. Everything should be put into ETL pipelines that allow you to load and transform data and store it somewhere else with a new state. And make sure that someone wants to modify it, let's say add a couple of more months to the training data, it's not done by directly, but rather the pipeline flow that produces this training data is modified, the pull request gets approved, and then make sure that you have agreed on who and when will run this pipeline so that the others' work is not affected. Model storage. In order to put one model into production, you and your colleague will probably have to rerun the whole modeling pipeline over and over again more than 100 times. That means that whenever the pipeline is run, the results and the outputs are stored correctly in the model registry. MLFlow is the most common model registry, but there are other model registries on the market that you can use for your purposes. The idea of storing these versions is the following. Not all of your experiments will be successful. For example, you want to make sure that you are able to easily come back to the model that you had 3 days ago without necessity to rerun the whole modeling pipeline because it might take too much time. That's why whenever someone runs the modeling pipeline, its results have to be stored along with the predefined metrics that you and your team have decided that you will be focusing on. This further allows a simpler way of choosing between the different models. Automating deployment or CI/CD pipelines. It's unlikely that you will build the ideal model from the first run. So what ideally you would want to do is to set up an iterative incremental process of improving. So you start with an MPP and then gradually you start adding additional features and additional capabilities to your modeling project. And during this process, you want to make sure that you do not only deliver the code, but you can also deploy it in the environment. So whenever someone merges a pull request into the main branch or to the dev branch, you want to make sure that this code is tested, is checked for errors, and is packaged and is deployed at least to the development environment. Usually, development process, if done manually, requires a lot of manual operations of putting files here, moving them there, and so on and so forth. Remember that your goal is to deliver new features to the users quickly and reliably. When working with CI/CD pipelines, you have a chance to automate all these things. Any manual interventions during the deployment process are your enemies. So make sure you don't leave this technical gap behind you. Some of these skills may not be very easy to find, but you can develop them as a team and work on them as a team to improve your team's performance. Remember, your ultimate goal is to deliver a software project to the business. Then this project has to bring real value and be integrated into the existing IT infrastructure. So start small, incrementally increase the number of features that are available in your product, participate in code reviews, make sure that the code that you produce is of a good quality and test it, and that the data and the models and the code are properly versioned. If you like that video, please smash that like and subscribe button, and see you next year.